Professor Manoj Kumar is working as professor at the Advanced Center of Research in High Materials, University of Hyderabad. He completed his MSc in Laser and Quantum Optics and PhD from University of Hyderabad. He is an experimental physicist, uses lasers to record spectroscopic signals from different kinds of materials like plastics, metals, and human tooth. He is working in the area of machine learning for the last 15 years. He uses machine learning for applications related to detection of materials and finding the concentrations. Let us give a warm welcome to our speaker, Professor Manoj Kumar. Today he is going to speak on machine learning and statistical significance.
Good morning. First of all, I'd like to thank Department of CS&IT for inviting me here. Just a second. Okay. So actually I prepared for 3 hours, but I have only 1.5 hours. So I have to see how do I pace. Since I am a teacher, I will be making it more interactive. So the first question which I want to ask is, how many of you are practicing machine learning? How many of you are practicing machine learning? Okay. Okay, how many of you know what is machine learning? Okay. And to give the context, so I am not from CS or IT or machine learning. I am a physicist, that is, I studied physics, I do experiments, and today I want to show how we are using machine learning to tackle problems which are of interest to science as well as daily life. But before going there, so I will have 1.5 hours, right sir? Yes. So, 1 baje tak. Okay, so first 30 to 40 minutes I would like to spend on this introduction, and then I would introduce my topic and tell how machine learning is entering into our area of interest. So what is machine learning, and particularly how is it important to science and tech, particularly the science? So they say it is the new math, that is the math of the 4th industrial revolution, and you would agree that it has touched us in one way or the other. And in science, it has been an emerging field for a couple of years, last 2 to 3 years. Almost all branches of science, physics, chemistry, biology, it has touched in the sense everybody is talking about it now. Everybody who is doing science, everybody who is doing research is talking about this and also thinking, can I use this too? Because it has become so reachable and so usable and so easy to use. But it's not a routine as of now. Like we use a calculator, or we use Python, we use MATLAB, we use R. It is not as frequent as that. But those who have done science, those who have done technology, they all know the mathematics. The mathematics behind what is happening in machine learning, everybody knows. But the problem is, the language is different. They call it linear algebra, they call it maths, they call it curve fitting, all such names. But once you come to machine learning, the language is slightly different. And now it's not only for CS&IT, but any teacher, not for BSc, not for MSc, not for BTech, even the school teacher must know what it is. And for school teachers, it is much bigger because the students who are learning in today's school, they are going to be in college in next 4-5 years, where machine learning is going to be a very common thing, very common thing. So what machine learning is? So obviously it deals with computer. So there is some traditional programming. What does it do? It takes some inputs, let's say A and B. Now we want to find if A and B are length of an object, which is either rectangle or square. Now the aim of the program is to find out, given A and B, that is length and breadth, is it a rectangle or square? So we know if A is equal to B, it is a square, otherwise it's rectangle. So you have a program, you have an input, you have a logic, it gives an output. So there's an input, there's an output, there's a program. What happens in machine learning? Things get flipped. There's an input goes as an input, even the output goes as an input. Output in the sense whether it's a rectangle or square, it was an output in traditional programming, but now that is going as an input. We need to have data, that is input, we need to have output, both goes to machine learning. And what does it give? It gives us a program. It will be clear in next slide. So this is referred to as data. Now what is data? Both input and output, which is both values of A and B, and if values of A and B are 8 and 14, it is a rectangle. If values of A and B are 7 and 7, it's a square. So this data is compulsory. This is the starting point of any machine learning application. And this is known as model. We all hear this term model. So whatever this program has been made, that is known as a model. So data, should it be numeric? So most of the time in sciences it is numeric. So data need not be 2 columns. Now if you see, there are 2 columns, length and breadth. That is 2 numbers for input. But it need not be. For example, it can be something like this, A, B, C and so many other columns. 100 columns, 1000 columns, 1 lakh columns, 1 trillion columns. It depends on the size of the problem and nature of the problem. So you need to have data and output, and a model program is given. And the data need not be numbers. Data can be characters, blue, green, yellow, red, anything. So we have been told in the introduction also, there are so many tools. These are some of the tools which one time or the other, not only we have heard them, newspapers have written about it, news channels have told about it, Jasper, Prisma, self-driven car, app builder, so many things. Now a little bit of terminology. So we said there is an input and there is an output. So you would connect actually. Input, what is the meaning of input? It is known as various other names in various other fields. Input can be known as independent parameter. It can be known as X, the X in the XY graph. In pattern recognition, it is known as a feature. Descriptors, variable. In physics and chemistry, it is known as structure. In statistics, it is known as predictor. So that's why I was saying everybody knows about it. Only thing is there's a difference in the term. Output. Output is a dependent variable. If it is X, output is Y. Property, it's a target or response. It is known as all these names. Now this is one of the important reasons why machine learning has gained importance and it is increasing the availability of data in various different fields. Obviously one of the places is internet. Every second everybody across the globe is using internet, and that is leading to generation of data, knowingly or unknowingly. Gene sequencing, that was one of the big projects where genes of all organisms were sequenced, so it is a huge database. On top of that, Internet of Things now, that is also so visible in the market. We see fans, geysers, refrigerators, all capable of connecting to the internet and ability to control across internet. So this is the, we can just see it. This is the reason for explosive growth of machine learning. Now how does the data look like? If you have practiced any of the machine learning programs, I'm sure you could have seen this data. Now you can see this, the data looks like this. 1 column, 2 column, 3 column, 4 column. All are numbers. They are known as features. For example, in this, there is a practice data set very widely used across all programs, whether it is MATLAB, or Python or anybody. So there are flowers, 3 different kinds of flowers known as iris, iris versicolor, iris setosa, iris virginica. Now, is it possible to tell using a machine, given these 4 numbers? What are those 4 numbers? Sepal length, sepal width. So sepal is this and petal is this. So given 4 parameters about the flower, can we write a program which can tell one of this is that flower? And what is that label? Sorry, that's wrong. So this one, so obviously we said this forms the input and this is the output. This is another data set, this is known as a housing data set, and this whatever you see is the input and this is the output. Output is a price. Now compared to the last example of a flower where we said there are only 3 possibilities, here it is not one of the 3 possibilities, but it is a number. 24, 21, 26, this is the price of the house depending on these parameters. Again, this is a very practiced data set, depending on different parameters. The person who is buying, what is the distance of the road, how much tax, how many rooms, like that. So is it possible if I give this many inputs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. If I give 13 numbers, is it possible for a computer to tell what is the possible price of that house? Now, this is another application of machine learning. Another data set. This is known as diamonds data set. You can see carat, cut, color, clarity, like that. So given all these parameters, is it possible to tell what is the price? That's the question we are asking. And you can see the data need not be numbers, like depth table is a number, but color, cut and clarity, they are not numbers. They are just words. So data can be anything. I'll skip some slides. So we said machine learning gives a model. So what is the use of the model? So you have the use of the model is with the new data. Once you have new data, use this model and take a decision. So in the context of flowers, tomorrow if you find a flower and you don't know what flower it is, measure those 4 numbers, give it to the model. It will tell one of these 3 things which of the iris flower it is. And the decision is always a label. In machine learning, decision is always a label. Label in the sense it's a number. So it can be 2 of these possibilities. It can be a continuous variable. Like in the case of housing data which I have shown, what is the price of the house? So it's going to be a number always. 2 lakhs, 5 lakhs, 10 lakhs, anything. So it's a continuous number. Or it can be a discrete number. So what does the discrete number do? It can tell 1, 2, 3. First floor, second floor, third floor. There is no number in it, but it is telling you class. It is known as a class, first class, second class or third class. Blood glucose or blood group. This is another common example which we can use to understand. If there is a blood sample and if I want to know which blood group it belongs. So there are only discrete possibilities, 6 or 7. A, B, C, D and AB plus, O plus, something like that. That is one question. And if I want to ask what is the blood glucose level? Now blood glucose level can be anything. There is no limitation of particular numbers. It can go from a minimum value to the maximum value and it can take any value in between. So this is the use of the model. So it goes something like this. You give sepal length, sepal width, petal length and petal width. Machine learning model is there, and then it will tell you which species it is. For example, in physics, now where does, in physics I can use, in physics there various parameters are there, for example, oxidation state, heat of formation, ionic gradients, tolerance factor, melting point, boiling point. You create a model, tomorrow you have a new material, measure these properties, and you can tell about some other property of the material. For example, defect formation energy. It can be anything. And does it work? In this graph we can see on the x-axis it is the actual values which we know, and on the y-axis machine learning predicted values. You can see they are following on a line. Bang on. So that is, this line tells us that machine learning can tell you the correct values. Obviously there will be an error. There are methods to evaluate that error. Now how does the model look? So model looks as if it's a big term, but model can be as simple as this one. A slope and intercept. Two numbers like 2.8, 3.21. That is the model. Or it can be something like this. N equal to 6, gamma is equal to 2.1, C, epsilon and some L. What is it? Don't worry, I'm just saying there are different machine learning methods and each one will give different models. Like N equal to 22, K equal to 15. This is the model. Or something like this. Different set of numbers. So when the input is given, output is given to a program, it will generate a model. Model means model is specified by some numbers. And numbers can be anything. It can be single number, it can be couple of numbers, it can be lakhs of numbers, it can be trillions of numbers. The model is that. So, how does it do? How does machine learn? What is the meaning of learning? So given a value of an input x, make a good prediction of the output y denoted by y cap. So this is what we have been saying. Given that input data x, it will tell what could be the correct value y cap. So this is accomplished by machine learning algorithms. What is the basis of working? So the algorithm works on the basis that strategies, algorithms and inferences that worked well in the past are likely to continue working well in the future. How does it learn? So we are giving input which is past. Let's say I have taken 1000 flowers of different three categories, measured and given it to the program. So it works for that. Now does it work for the 1001st flower? So that is the basis on which this is working. That strategies, algorithms and inferences that worked well in the past are likely to continue working well in the future. And a core objective of a learner is to generalize from its experience. That is, as the experience grows, it becomes more and more general. So there are two ways in which a machine learning algorithm can be built. That is, now obviously we have to predict a number. We have to predict a label. So how does it do? There are two, broadly, if you take all the algorithms, they will fall in this least squares and nearest neighborhood. These are the two commonly used approaches. So what is least square method? So this is little bit mathematical. Just let me see. So let's say we are working with a linear data where A and B are unknowns. So the aim of least squares is to adjust this A and B in such a way that this parameter known as chi-square becomes minimum. So it predicts something. This is the prediction of the machine learning algorithm, and if you take the actual value minus predicted value, for what values of the parameters this particular object is going to be minimum. So it will find parameters for which, now the loss, this is another name. This particular function is known as loss, which is the difference between the actual value and predicted value. Okay, there are some programs, but I could not connect my laptop, so I will not be able to show. So loss, there are different types of losses, like mean absolute loss, mean square error, cross entropy loss, root mean square error, Manhattan loss. There are different types of things. But in each thing you will see, this is the known value and this is the predicted value. Known value and predicted value. So maximum likelihood is used to estimate these parameters. So what do? Randomly choose the initial values of the parameter. Because we do not know what is the value of the parameters. So you randomly choose some parameter, some starting point, then predict y. Using this model, predict y. Now you have y and y predicted. Now you can calculate the error. Remember the error. Now change these parameters. Change these parameters again, let's say randomly. Again calculate the error. You have the first error and you have the second error. When the second error is less than the first error, forget the first one. Remember this. Continue this loop until you find a place where the error is minimum. There is a method called gradient descent method, that is changing, let's say A and B are parameters and you want to change. How do you change? So they are changed by taking the gradient of the function, and gradient tells you in which direction you should move so that the change is fastest. That is the only logic. Again, this is a simulation, but I will not be able to run.
It is also.
Huh?
Wireless is what?
Oh, wireless is working. This is also not working.
It is audible, sir. I think.
Yes.
That's very
Yeah, इसी से बोल लेंगे. I can move around, but I have changed the slide, so I will not be able to move around. The second approach is nearest neighbors. So it uses k nearest neighbors. That is, k can be a number. 3 nearest neighbors, 5 nearest neighbors, 10 nearest neighbors. So the logic is like this. Select the number k, that is select 5. Calculate the Euclidean distance to all the points. Then out of which take a call. Let's say I want to find out whether it is a type A or type B. So you have data, measure the distance of this unknown from the 5 points. Now it is closest to, let's say, type A for 3 and type B for 2. So we decide that this is type A. So this is the logic of k nearest neighbors. So there are broadly 3 types of things which machine learning does: unsupervised learning, supervised learning, and reinforcement learning. So in supervised learning, what comes as classification and regression, and in unsupervised learning, it is a job like clustering. So let us look at these 2 things, what regression means. So I have an independent variable x and dependent variable y. This is the data. We want to know what is the function which describes the relationship between dependent and independent variables. So that is the task of regression. Whereas in classification, it is something like this: independent 1, independent 2. So this is the data. So independent 1, independent 2, it can be, let us say, height and weight of a person. and based on that you want to, let us say, decide which country that person belongs to. Height on x-axis, weight on y-axis. So it can be anything like this. So now we want to find out where can I draw a line so that that is a boundary to decide country A and country B. I can either draw a line like this if the data is this, or something like this. In the earlier case there were some errors because on the bottom side of the line this point is there. If I draw a line like this point will be classified as country B and this point will be classified as country A. But can I draw a line like this? So this is type of non-linear kind of a job. So it's possible. So if you look at some examples, supervised learning or regression, you might have heard this term: support vector machine, discriminant analysis, Bayes, nearest neighbor, neural networks, SVR, GLM, ensemble method, decision trees, neural networks. They are all algorithms which are there, or for clustering, hierarchical clustering, Gaussian mixture, neural networks, or anything. So there are whole lot of methods. So what is needed? So there are actually three things which are needed. The first one is the domain knowledge. So why do I want to use machine learning in the first place? Do I have the data? Do I have the question? So unless I know something about the flowers, I will not be able to go and ask these questions or create the data for myself. So provides the understanding of reality in which a problem space exists, also known as domain expert. If I am working with blood, I should know something about blood. I should be related to some medical science, or I have studied some biology. Then that is step one. Step two is mathematics and statistics. Very important because this gives us the theoretical structure in which these problems can be examined. And the third one is the computer science. You have domain knowledge, you have mathematics and statistics, but where do you implement this? It is the computer science. So it gives environment in which these things can be done. And all these tools are that. So you have intelligence, using that we can make artificial intelligence. So where do we start? First one is data. Either you have it, or you create it, you download it, or you make research, you measure, or something. If you have data, it's okay, you can directly start. There are so many places you can do: Python, JavaScript, R, C++, MATLAB. MATLAB, there is a dedicated toolbox. One doesn't need to know even anything. It's drag and drop actually. Python, there are powerful things: scikit-learn, TensorFlow, Keras. In R also there is a package called Caret, which is very powerful. The amount of programming is very, very less. So what do we do? So first you get the data. Obviously the data is going to be not so clean, so clean the data, because the amount of data is so high, we want to visualize it and then learn the data. That is, create a program, algorithm, and then test it, whether it is working or not. So how do you test the data? How do you know the model which you have created is working? So there are various metrics like mean absolute error, mean square error, RMSE or R square, or for classification and prediction. See, it goes like this. This is the data which is there. I have created this line. In future, if a new data point comes, what is the value of y? That is the question I am asking. So there is going to be an error. Always there is an error. And in classification problem, if there are two categories, it belongs to A, but the output can be A or B. So this is actual A, output can be A or B. So if all the time A is told as A and B is told as B, then that is like an ideal case. But in reality what happens is, the A is given as B and B is given as A sometimes. So it can be 70% of the time, 80% of the time, the program will work. So how do you characterize the algorithm, whether algorithm is working or not? So that's why when we are using even ChatGPT, things turn out to be wrong. Even in the Google search, the search turns out to be wrong. It's not correct all the time. Most of the time it is correct, maybe 90% of the times it is correct. So this enables us to characterize that error. Log loss, accuracy, precision, recall, F1, confusion matrix. These are the things. So how do one proceed? Take the data. This is the total data you have. Then split it into two parts. One is known as training data, another is known as testing data. Using this 80% of the data, you train the algorithm. Like whatever algorithm is taken, you create the model. Training means you create the model. Now, is the model working? Obviously, we have to test it. So this 20% of the data which we have kept aside, we can use it for testing. Obviously, there are so many other strategies which can be used. And because remember, when you are using testing data, you know the output. We know the output. Use the algorithm, use the model. It gives an output. Then compare the output given by this model to the known output. So that characterizes the error. To what extent this algorithm is correct. Can I use it or can I not use it? So this is another way of doing this. This is known as k-fold cross-validation. That is, you should have total data, divide it into 5 parts. That is, k is equal to 5. This is known as k-fold cross-validation. Use 4 parts for training and using this model, test it. Obviously, there is going to be an error. Call it error 1. And in the second iteration, keep aside another chunk and keep on repeating this process. 5 times you will get 5 errors. Add those errors and divide by 5. That gives you cross-validation error. Leave one out, cross-validation. This is again another way of testing it. You have the entire data. Just keep one data aside. Create the model with all the other data. Now, take this left out one and test it. Repeat this process for all the things and then that will give you leave one out cross-validation error. Okay, we can stop here actually and I'll go for now, before we go ahead, we are telling that there is a model, we have to give input and it gives you an output. So how does this output look like? I have shown you what input looks like. How does an output look like? So there are two problems. One is regression, which gives a continuous number as output. So the output will look like a number. But in case of a classification, where there are only 3 flowers, how is the output going to look like? So is it directly going to tell that this is flower A, flower B and flower C? Yeah, we will be encoding it. So obviously the computer will not understand flower A, flower B, flower C. We will be telling it as flower 0, flower 1 and flower 2. So but is it going to tell flower 0, flower 1 and flower 2? So what's going to be the output? This question is very important for my next part. Sorry. So what's going to be the output? Because if I don't use, if I'm not a practicing machine learning person, I would think that the computer will tell flower A, flower B, flower C. क्या ऐसा होता है?
So not unless the machine is trying to do so.
Yes.
So not unless the machine is
Machine is trained. Machine is trained. Obviously, you have data, you have trained it, there is a model. And I have an unknown, I have put in it, and we see it as it will tell flower. But what I am asking is, what is one step behind it?
because it itself it doesn't know that what flower is. We are given a 0, 1, 0, 1, 2. Yeah, label encoding. But see, there are two different ways. For humans it is flower A, flower B, flower C. For computer it is 0, 1, 2. So now how the computer is going to tell? So it is 0, 1 or 2 directly like that. That is one possibility. The computer is going to tell it is 0, 1, 2, and then we know what is the meaning of 0, what is the meaning of 1, what is the meaning of 2. That is one possibility. But does it happen like that? It doesn't happen like that. Because what are these algorithms based on? These algorithms are based on principles of mathematics and statistics. Right? Because if you see, if it is a rectangle and triangle, let's say I am juggling around with the example. If it is a rectangle and triangle, it is okay. You give two numbers, and out of which, if it is length is equal to breadth, it is going to tell it is rectangle. Otherwise, it's going to tell it is square. But the real world is not like that. There are million parameters. There are billion parameters. Even let's say this one, autocomplete. There is an autocomplete sentence. We start writing. After the first word, it will suggest the second word. So what might be happening? So it just goes into the dictionary and gets that word and puts here. So in any case, I told the job of machine learning is to give you a number output. That is the only job, the label output. And that label output is going to be based on probability. So it's not that it's going to tell flower 1, flower 2, flower 3. It's going to tell the probability of being it, flower 1 is 75%. The probability of it being second flower is 20%. The probability of it being third flower is 5%. So this is the output it comes. If there are 3 flowers, we get 3 probabilities. If it's a sentence writing, if there are 1 lakh words in the dictionary, we may get 1 lakh probabilities. And the most probable thing comes out. Since flower 1 has a probability of 75, it tells it is flower A. So it works like that. So it's always probabilistic. Machine learning is always probabilistic. And that's why it is important to have something called statistical significance. Now how do we know that this is significant? Further, there are different ways of doing it. Since statistics is there, so it tells you what is the significance. So it refers to the fact that obtained outcome as a reason for its occurrence, and it's not happened due to chance. Because remember, it is not a human which is making a judgment. If it's a human, then we have a lot of cognitive ability and intelligence. Based on that we will do. But as far as computer is concerned, the data which it has been given, the 1000 rows of data which it has been given, it will depend only on that. Whereas human, in one sense, has been trained with billions of experiences beforehand. But as far as computer is concerned, it depends on only those 1000 rows. So the decision that has been arrived, by chance, is it by chance that the data is not good? There is so much noise in the data, that's why this output is coming. So it's a fundamental aspect of inferential technique known as hypothesis testing. So statistical significance does not focus on practical significance or importance of outcome, but assures the reliability of the outcome. So the significance tells us that outcome is reliable or not. So this can be determined by hypothesis testing. So these are some of the common terms which you encounter. So there is something called population. It's an infinite collection of elements, individual items, observations, etc. Sample is part of a subset of population. But the basic problem of the sample is generalization. So why this is coming? So the data which is there, for example, the flower case. How many entries we are going to give? Let us say we give 10,000 entries. So is it the infinite number possible? So that is only a subset of all the possible things. So that becomes a sample. So there are parameters or static which describe the quantity. For example, the mean, the standard deviation, like that. So the distribution of the value of statistics which would arise from all possible samples are called sampling distribution. The standard deviation of sampling distribution is called standard error. So it's like this, if you have 1 lakh flowers and sepal length is there, so they will be distributed. They are not going to be same value. If they were all of them were same value, then there was no need of any statistics or anything. We would have told it is deterministic. So many times we will see this kind of a distribution which is known as normal distribution. Are you familiar with this? If you take all the values, for example, one column, the sepal length, there were 4 columns in the flower data. You take one of the columns and draw a distribution. Most likely it will look like this. And most of the numbers would lie between this something known as 95% confidence level. So there is something called standard deviation first of all. So you take the numbers, you draw this bell-shaped curve. So how many values are lying, or what is the limit into which 68.27% of the values are lying with respect to the mean? This is the mean, this is the center value. So how much should I go left side, how much should I go right side, so that 68.27 numbers are within that. That is known as standard deviation. And if you go 2 standard deviations, this side and this side, 95% will be there. This is the most standard definition used in machine learning, 2 standard deviation. And if you go for 3 standard deviations, almost 99.99% values will lie. Yeah, there are 2 things. One is known as, in hypothesis testing, there are 2 things, null hypothesis and alternative hypothesis. So null hypothesis states that there is no statistically significant difference between the parameter and the static being compared. Alternative hypothesis, on the other hand, it is the opposite of null hypothesis. It says statistically significant difference does exist between parameter and the static being compared. I'll give you an example. So the probability comes as, if the probability is less than 0.05, we can be confident that the output which is coming is reliable. Let me go to the example. For example, this kind of a data is there. Now, on the x-axis we have homework score, that is homework marks. On the y-axis we have final exam marks. Now if I want to ask the question, does final exam marks depend on homework? That is, if I do the homework, then my final exam marks are going to be good or not. Now if I collect data, let's say it looks like this. Now there is something called correlation, which is R. There is 80% correlation, that is 0.8. That means the correlation is high. So we can reasonably say that if a student does homework, getting higher marks in the final exams are more likely. But it's always like, what is reasonably close? So am I happy with R equal to 0.6 or R equal to 0.4? or r equal to 0.9 or r equal to 0.99? That is the question. So we ask this question. So what is the probability that r can be greater than or equal to a given number? So it depends on number of data points taken. If my data has only 3 points, then predicting anything would be very difficult. That is, if I take 3 students' marks and draw such graph, if I take 3 students' marks and draw such graph and ask the same question, obviously we know the reliability of answer is going to be very, very poor. That is, reliability of me telling whether the examination marks will depend on the homework or not is going to be very less. So that is what most computers calculate. It is known as probability P. You can see this table. I have reproduced this table here. If I take only 3 students' marks and if I ask 0.8 is my cutoff, the probability is 41. That is, probability of null hypothesis is 41. What was the null hypothesis? It is by chance. That is, if I take only 3 data, it is not reliable. But on the other hand, if I take, let's say 10, let me take 10 students and ask the same question, 0.8, 0.5%. That is probability of this correlation, that is student getting more marks in the final exam if homework was done correctly, is by chance is 0.5%. That is, I can reject null hypothesis. When I reject null hypothesis, what is left? The alternative hypothesis that the student gets good marks not by chance but it is really happening. So this is what happens across all machine learning algorithms, because it predicts something. You give data, you predict something, but is the prediction correct or not? Again, it depends on number of variables, n. So when we do machine learning, it is very, very important. How much data should I have? If I have 10 numbers, is it enough? If I have 100 numbers, is it enough? If I have 1 lakh numbers, is it enough? So this is always a situation which has to be answered. So the probability obviously depends on n. You can see. So any machine learning programming language will have a what we call function which will calculate this p value. So based on this p value, we decide whether the answer which is coming is acceptable or not. So next, let me move to my domain specific now. So in the next 20-25 minutes, I would like to introduce what is my domain, where is this machine learning come in, and what are the decisions we take. So machine learning means data, right? So the first thing is I want to tell how do we record data. So before recording the data, what is the motivation? Why is that we are interested even in generating the data? So there are certain questions which we want to ask. We want to answer those questions. To answer those questions, we decide to use machine learning. Hence, we need data. So since all of you are from computer science, I'll take a little bit of time to explain how this data is generated. But before going, let me ask a couple of unrelated questions. Okay, but in any case, why I am asking is, there was a time when there was a lot of controversy about this, right? Even government put a ban on sale of these things. Do you know why?
Because there was an MSG content
Yeah.
harmful?
Yeah, let us not go into specific. There was some harmful element which was supposed to be in a certain limit, but it was found to be having higher value. So that's why it was off the shelf. This is the question which we encounter every time if I'm buying honey, particularly if I go roadside. If I'm buying from a company, there's a brand and seal on that, so that gives confidence. But if I'm buying from some unknown source, then the jaggery solution, one can put 60% jaggery solution, 40% honey, I'll not be able to detect. Is it possible to detect, or how do I? This is the question related to anything, not only adulteration of honey, but adulteration of any food item. You heard of this controversy? Whenever such controversy comes, the news channels goes haywire. Plastic rice. How do we know? Or how do even they know? The news channels which were so hectic in this, how do they know? They say namakame jivitam. So they want us to believe. But how do we know? The gold which we buy is 24 carat or 23 carat. It makes lot of difference. 23 carat to 22 carat. How does it make a difference? While buying it is okay. We don't know. We are happily buying it is 22 carat. Let's say it is 18 carat. We use it, nobody knows it. It will come into picture when you go and sell it. Then he is going to tell this is 18 carat, not 22 carat. The difference comes there. So it makes diabetes. So is it possible to measure the blood glucose without taking the blood outside the body? Is it possible? Have anybody heard? Not only blood glucose, anything. Now blood sample testing is so prevalent, everybody does it across the world. So is it possible to do all those measurements without pricking the blood out? What do you think? Could it be possible?
See, there are so many other factors are there which
Yes. There is another concern whenever we go public place, particularly the airports. This is very strict. They want to check what is contained in the baggage. What about this? Is it a problem? It is a problem. So let us see. Which mango is sweet? If there are 10 out of them, is it possible to? This is very relevant to us, right? Every day we buy.
the more ripen.
Yes. For us it is okay, but for a farmer who is selling his hard-earned thing, at what time he should pluck? If that decision is in his hands, can he earn more money? Is it possible? Sulfur is found on the moon. What did they do? How did they do? Did they bring material to earth? But how do they know? They said some instrument is there, so and so thing. So there are so many examples, adulteration, science, everyday life, everything. So can we use light, and is machine learning useful in such things? I'm not going to tell, I'm going to ask, is it possible? Two questions, light, that is domain specific, but since we are talking of machine learning, could machine learning help in answering any of these questions?
and similar such questions. Is it plastic rice or not? How much blood glucose is there in the blood? If a gold is given, how much carat gold it is? Can we use machine learning?
Yes.
How?
By applying intelligence and algorithms. Some
Yes.
intelligence algorithms. Yes.
Yes. So if you look at all these cases, you can see it is similar to what I have told in the introduction. Either I want to know whether it is plastic rice or actual rice. Two possibilities. Or I want to know whether it is honey or jaggery. Or if it is honey plus jaggery mix, I want to know how much honey is there. Right? So either it is two-class problem or a regression problem. All it boils down to is generating the data. So if I want to use machine learning, I have to generate the data. So what we do is, all the matter which we see around contains solid, liquid and gas, or it is either atoms or molecules. This much we know. When we shine light onto this, depending on the concentration, depending on what atom it is, the atoms are going to give signals, or the material is going to give signals which can answer all of these questions. And how do we do? A typical setup would look like this. We have some light. Send it. Light means it is a white light. So white light contains all colors of light. Send it into it. Put the sample of interest here, and then it passes through the sample, and here is what we get the signature. So if I am interested in honey and jaggery, take the honey and put it here. Take different types of honey, generate the signal. Take different types of jaggery, put it here, generate the signal. And in the last column, write whether it is honey or jaggery. Honey, honey, jaggery, honey, and like that. That becomes my input. And we have to do some modeling, which is machine learning. Tomorrow if some unknown sample is coming, same, I'll get it and put it here. It generates a signal. Put the signal into the machine learning model. It is going to give us probability of it being either honey or jaggery. So depending on whichever probability is higher, we decide whether it is honey or jaggery. Let us look at this video. आवाज सुनाई दे रहा है क्या? So the device which we are talking need not be very big. It will be very small since it is a light-based device. So this is one of the examples from the internet. So it has both the components. You see, it can tell whether the food item contains fats, carbohydrates, proteins, like that. First level. Second level, it can also tell how much. So both the problems can be addressed. Fats, carbs, protein. So he is just only explaining the app. So look at it. This is put on the sample. So it is collecting the data. Couple of seconds. Now we can see it has told how many calories that had, how many proteins, how many fats, like that. So obviously this one scan was the unknown input and there is a model sitting on the cloud. So what data it generates we don't know. Let's say we're not going to specific. It generates some data and that data when it went to the cloud, it has distinguished that fats are present, carbohydrates are present, and then next level it has also told what is the percentage or number of, now this is percentage actually, how much percentage of each is there or how many grams, for every 100 grams, how many grams each is present. So this technique is known as Raman spectroscopy. Again, if you look at the experimental scheme, it will look similar. There will be some light and there will be some other components, and this is the sample where you keep the sample, and then it comes and falls on something known as a spectrometer, which is the signal. So this particular effect was discovered in India by Professor C.V. Raman almost 100 years ago. And how does the signals look? Let us see how does the signals look. So when I say signal, it looks like this. Something known as wave number, which is the color of the light, and on the y-axis it is how much light of this color is present. So this is referred to as a spectrum. This is known as Raman spectrum. Now in the next slide you will see where is the information. You can see some numbers, that is, this is a 0. So minus 153, minus 218, minus 472, 153, 218, 472. So the experiment, it looks like this. This is the laser. When it falls on the sample, you will see as if nothing is there, but if you put something like rejection filter, you can see different colors which are not present in the sample. So this is the signature. So it's machine learning. It doesn't mean that we give some data and it automatically gives output. That output should be related to the sample of interest. The color which you are seeing depends on the sample. Different samples have different color output. When the laser falls on the sample, it will give out the signal, that is the color, in different colors. If that does not happen, then neither I can decide nor machine learning can decide. The color should change depending on the sample. Does it change? Let us look. They are the slides which I am skipping because this is not for this audience. So little bit maybe unrelated, but each molecule, that is whatever materials we are talking of, have something called bonds, and different bonds, when they interact with the light, they will produce different colors of light. Now let us look at this. irrespective of what science is there or anything. This is the Raman spectrum for 3 different samples, 3 different types of plastics: PET, LDP and PS. I'll tell you what all these things are in my next slide, where I will show you the detail about these things. But there are 3 different kinds of plastics. Like this is one kind of a plastic, this is another kind of a plastic. And is it important to know which is which? Irrespective of that question, does these 2 samples produce different signal? Let's look at this. You can clearly see there is some signal here for this sample, there is a signal here for this sample, and there is a signal here for this sample. That is, when I generate data for this sample, they are going to be different. Hence, I can use light to detect if this plastic is PET, LDP or PS. The second question is, can we use machine learning? That will come in the next part. For example, if the pearl is original or it is duplicate, the original will look like this, and if it's a duplicate, it will look like this. It is as simple as that. So there is information. There is the information in the data. And what is the data? These are all numbers. X-axis is some real number line, Y-axis also is some real number line. We are talking of rice and plastic rice. This is the signature of plastic and this is the signature of rice. There is a clear-cut difference. To the eye it may not be different, but once you put in this spectrometer, you will see these signals and there is again information. Similarly, maida and atta, there will be some similarities because they are coming from the same thing. But for example, you see there is some signal here which is not here. This signal over here is here, but there is only small amount, like that. Sugar and honey, again we can see honey almost has no structure, whereas sugar there is so much of signal. Diamond and some other quartz, you can see there is only one signal here. So you can see different sample will produce different signal for us.
So almost in every situation, slide will be helping us to capture to generate the data.
Yes, almost all situations, yes.
What about numerical, the textual, because these are some solid materials.
Solid materials. You can use gas also. We can use liquid also.
I'm not in this, because machine learning algorithms are playing their role in textual data as the modality. Textual data.
Texture of?
If it is a speech,
Yes.
numbers are generated.
Yes.
If it is a text, dictionary uses are there to
Yes.
generate numbers.
Yes. But these are also numbers.
Yes. No, I'm talking simple text. Can light help us in?
Oh, not simple text. No.
That's what.
Okay. No, text is on computer. It's not material, no?
That's
It's not material. Now this is another example where it's of the second category. How much is present? For example, it's a mixture of 2 components. And what are so what they are may not be so important. It is known as RDX and AN. As you can see the percentage is decreasing of AN, and you can see the signature. When the 100% is there, this is taller, decrease, decrease, decrease and decrease. That is, when I change the concentration of the material, like amount of jaggery in jaggery plus honey, there is going to be some change. Only then any tool can be used. So this is another way. Not only the signature is going to be different for different samples, for each sample, if its quantity changes, the signal also will change in terms of the strength of the signal. Now this is going to be data. These are all numbers, so we will be using these numbers to build machine learning models. Let us look at another example. Now this is another experiment where there is a laser coming from this left side. This line which you are seeing is the laser. There is a lens, ordinary lens, which we all use it. Pass that laser through that lens and something happens here. This is in the open air. Open air also there is some material present, oxygen, nitrogen, carbon, hydrogen. So instead of air you can get any other sample. So this is what they have done on moon. They have taken a small laser, something like this, put the lens and focused it onto the moon surface. The moon surface has generated something like this. And this signature will be different for different materials. So this is another technique. To the eye it looks white, but when you put instruments, there will be information which is useful. So it may look like this. On the x-axis the color, which is known as wavelength in physics, and on the y-axis it is the count, like how much of that light is present. For example, at this wavelength the amount of light is less, and at this wavelength the amount of light is more. And this signature is going to change. I am going to show some examples. So this is some signature. Let's say when we use water regularly, some layer forms on the taps and buckets. If you take that material, the signature looks like this. Yes?
If we want to take data from any tangible material in a real-time environment,
Yes.
so I think it won't be possible to take the data without integration of physics. Here you have given example of spectroscopy.
Yes.
So I think it's not possible. If we want to directly use ML, then
Yes.
we have to take the data, secondary data.
Yes.
If we want to take the real-time data
Yes.
from any tangible material,
Yes.
like maybe biomaterial or any. So
It can be taken. Biomaterial can be done. See, the biggest proof is we have sent a instrument to the moon. It has collected data. It has sent us the data, and we have analyzed that data. So, if it can be done on moon, here it is possible, and people have done it. And I am going to show one of the examples. How did we do? This is brass sample. You can see copper, presence of copper, zinc. This is the eraser which we use. So there is a magnesium, there is carbon,
But you observe the pattern. It is not important what is physics in this. I am just trying to show differences come. Aluminium, it is a metal. Graphite, again carbon is present in graphite, this is the carbon. Jaggery looks like this. Maybe real life situation, because in the lab there is a comfort, I can take the sample and put it in the instrument. But you can see this particular setup, the sample is very far up, about 6 meters from this point. So there are instruments which can go for up to kilometers, because that is the advantage of using light. If I use a light, I can send it kilometers across, it will generate some signal, and using that signal I can find. So let us take some use case now. I have shown you that I can use light and I can generate some data. Now can I use that data to do something? So let me present this, some of the latest result. Let's ask this question. So do atomic elements present in teeth play a role in sex estimation? That is, if I have a tooth, can I use that tooth in one of these experiments which I have shown you, and then determine the sex, male or female? Now one would ask, what is the use? In forensic, for example, when they find something, some tooth, they want to know whether it was male or female. Or in archaeology also, when they dig out, they get some things. So in that context, this will be useful. So let us see, how does results look? What did we do? So the aim is we want to check if there is a correlation between the levels of these elements present and the sex. So this was a study done with about 250 samples. The teeth were extracted from various, we collected from various doctors, dental doctors, in and around Nagpur. So these are our samples, about 250, 258 tooth were used. So a lot of data was collected, date of birth and then age and their habits, all such things. Then the same experiment. There is some light, but instead of sample, we get the tooth and put it here. And what does it give? This is our lab, this is the experiment, actual experiment. It looks like this. When I put tooth, the light signal looks like this. So we collected from different age groups also. We are trying to see if age also can be determined, because that is also very important question. There are the various food habits. Yeah, now you can see there are a lot of signature peaks. Now how was the model setup? We had 250 tooth. So for each tooth, I think we have recorded 5 such signals. So male and female, it was about 50-50, 120 tooth each. And we have recorded how many? Is it written? Let me check. No, it is not written here. If I am not wrong, 5 spectrum were recorded for each tooth, different points of the tooth. Because it is, when we collect data for machine learning, it is important that we incorporate all differences.
If you get uniform data, then the program will not work properly. So all this 120 tooth per group were taken and 5 spectra were recorded. So it becomes 600 per male and 600 per female. So this forms our data. So 600 rows, 600 plus 600 is 1200 rows. How many columns? So this data which you have seen, this particular data will contain about 2000 numbers. So for each tooth there are 2000 features. So our data will consist of 1200 rows and 2000 columns. And then what do? Is we don't take all this data, we take data around these points wherever these tall buildings are visible. So that becomes like this, certain numbers, about maybe 50 numbers. So finally the data becomes 1200 rows into some 50 columns. So now that is the data that is used for machine learning. Call it K-fold cross-validation or training testing. All such things are done. But here you can see, for example, this number which is related to potassium, 253. Sorry. There is a small thing here. This is potassium. So, does it play a significant role? Sorry. So 251 nanometers to 256 nanometers. So like this we take all the data and then what happens? Are there differences? Now if you look, there are random differences. In some cases the amount of light given by male tooth is higher, and in some other tooth the light given by female tooth is higher. But are there significant differences? So you can see it gives us something called p-value, and it is highly significant because p-value is much less than 0.05, that is 5% level. Almost all the wavelengths. So this gives us a handle that given a tooth, we don't have to even work with all this wavelength. We can take any of this wavelength, any of one of these peaks, and decide whether it is male or female. Let us look at another example. This particular one. So this is the spectrum which I was showing you little earlier. There are 6 types of plastics depending on the nature and the name, which is numbered as 1, 2, 3, 4, 5, 6. They are known as recycling code, and 7 is given as others. So this is important because the amount of plastic which is generated is so high. Now what do we do with this? So recycling is one of the options. So if you want to recycle, it has to be sorted, because when we after use it is all mixed up. So if you want to recycle, it has to be sorted. So presently it is done manually. So if we use light based techniques, does it make the job simpler? So that is the question. Let's see how does the result look. So this is the data. So we collected 10 different kinds of samples falling into 7 categories obviously, but there were 10 samples with different names. These are all collected from these local places where they collect the plastic. All kinds of plastics we bought. These are the
cut pieces of those samples, and then this we have seen. This we have seen. Now this is the data. I have shown you two light-based techniques. One is known as Raman spectroscopy. This is how the signals look. On a broader view, it shows all the samples have different signatures, but if you look closely, some of the samples will have some similar thing. For example, this one and this one, 2 and 4. Look at 2 and 4, they are similar, and then to some extent 5 also. But there will be some differences which are not obvious to the eye. They can be used, and in the process of training, all this can be identified. Now, how does the second technique look? I'll directly go to the data. Now this is how the data look for 10 different samples. Now here the job is very difficult humanly because almost all the spectrum look the same. So in such cases, the machine learning becomes much useful, because if it looked like Raman spectra, then just by looking at it, a human can decide. But for this case, you can see, for example, here all of them have signature. Here all of them have signature. Here all of them have signature. But if you zoom in and see, there will be a lot of differences which are reproducible, which are depending on the sample. So various ways we can do. For example, look at this. For example, in this graph, you can see the signal strength depends on what sample it is. So I can take the signal strength and decide which sample it is. Or I can do the full scale machine learning. This is the principal component analysis, and you can see each cluster, each of this group belongs to different samples, like PP is here like this. So this clearly tells us that although the spectrum was looking very same, it had information which can be used for machine learning. So when we applied machine learning, what was the result? Let us look at the identification rates. There are three things, three different ways we have done the experiment, but don't worry about these three things. You can look one of them. For one kind of a plastic, the identification rate was 98%. For this kind of plastic, it was 97.1. So you can see the identification rates can be very high. The misclassification would be about 2 to 3% only. And if you look at overall accuracy, it's almost 97%. So it's not only the data generation is easy, but the confidence levels are very high. And how much time it takes? So once we give the data, it takes about 50 milliseconds to decide. And how much time it takes to record the data? It takes about 2 seconds to record the data, and maybe another 1 second. So within 3 seconds we can tell what the sample is.
think I can stop here. We can discuss your questions or queries. Questions, queries, or any discussion? Yes? Yeah, no questions, we can stop. Thank you for your patience.
Sir, one question.
हाँ बोलिए.
सॉरी, अगर हमें कोई एलिमेंट को पता करना होगा, सपोज मून पे हमने वो लेजर भेज दिया,
Yes.
वो डिटेक्ट कर रहा है वहाँ पे कोई एलिमेंट है.
Yes.
सर पीरियोडिक टेबल के हिसाब से हमारे पास 180 एलिमेंट्स हैं.
हाँ.
वो हर एलिमेंट हर एनवायरनमेंट में डिफर करता है. जैसे हम हाइड्रोजन की बात करेंगे, अगर हम उसको कंट्रोल एनवायरनमेंट में रखेंगे तो उसकी कंपोजिशन अलग रहती है, और अगर हम उसको नेचुरल एनवायरनमेंट में रखते हैं तो उसकी वहाँ कंपोजिशन अलग हो जाती है. तो किसी एलिमेंट को पता करने के लिए हमें सब क्या जरूरी है कि हमें सब के सब 18 एलिमेंट जो हमारे पास है सबके सब का केमिकल कंपोजिशन या उनका जो फिजिकल अपीयरेंस है, कहाँ किस एनवायरनमेंट में रहता है, वो करना जरूरी है कि मशीन ऐसे ही पता लगा सकती है विदाउट एनी डेटा कि ये एलिमेंट कौन सा है.
Yes. बहुत अच्छा क्वेश्चन है. See, what he is asking is hydrogen on moon or calcium on moon may be different from on earth. Now there are two different kinds of things. If it is a material, it can differ, but we are talking of atom. When I say sulfur, it is atom. That is point number one. Sulfur will be sulfur anywhere in the universe, either moon, Mars, exoplanet, wherever it comes, sulfur will be sulfur. Now what are we checking here? The response of sulfur when light falls on it. That is also fixed. So it doesn't change. Its chemical reaction may change, but the signal which we are using to determine whether it is sulfur or not is same. Hydrogen, let us say, it gives red color. Sodium, it gives yellow color. That is same across. So that will not change. So if that changes, then we cannot find out. Let's say if hydrogen gives red color on planet Earth and blue color on moon, we cannot tell, right? So that is the fundamental thing. It is fixed.
Sir, my question is that when you are showing this figure diagram, there are light is passing, but some is making a circle. So there is means there is a space. Here to from here there is a nothing is there.
Yes.
But some is space is making a circle. What is this circle means? Why is showing here not showing the circle, but
yes.
here is in between they are showing the circle.
Yeah. What sir is asking a question is, in the second video which I showed, there was a lens, light was passing through the lens, and after propagating some distance, I could see some white light, nothing happened in between.
Yes.
Yeah, why this, what does this lens do is, it will concentrate all the light into very, very small portion.
Convergence of
It is convergence, it is known as, in the childhood we used to play, right? Take it and put it on some cotton. Only if you put it at a distance, cotton will burn. Because the light has to get concentrated. That is, it has to converge. So when it converges, only then we can see the effect. Some minimum light is required to see the effect.
So it is also useful for anything.
Oh, it is useful for many, many things. Laser is there, it is everywhere. It can blast kidney stones, it can remove hair, it can remove whatever. So if you take our human body, for each organ there is a laser. Tooth के लिए अलग लेजर है, stomach के लिए अलग लेजर है, eyes के लिए अलग लेजर है. Like eyes, they do operation, right? No need of glasses. They will correct the lens itself, the eye lens, not this lens. Eye का जो lens है, उसको. And in any other application area you take, for each application there is a laser. We can find the distance, let us say. Using light, they find distance. And nowadays we get outside this carvings, no? एक transparent material रहेगा, उसके अंदर we can get our photo engraved, laser engraving. ऐसा thick material रहेगा, glass cube, उसके अंदर, उस मतलब light वहाँ पे focus होगा. बाहर तो it is smooth, but inside you will see that whatever Taj Mahal or our photo is there because it is focused at that point. This is the focusing effect. Huh.
Sir, why we use laser light?
Yeah.
Why we not use other?
Yes, I said it needs some minimum light. If I use ordinary light, this effect will not be produced. There are two things. In the first experiment which I showed, that effect will be produced, but it will be very little. So I have to collect the signal also. If I send more light, I will get more signal. And in the second case, there is a minimum amount of light to get the signal itself, which cannot be done with ordinary light. So ordinary light to laser, there is, let's say, 10 power 6 to 10 power 10 orders of change. It is that much difference.
Any questions? On behalf of ATAL-FDP, Department of CS&IT and all the participants, I would like to thank Professor Manoj Kumar sir for his enlightening lecture on machine learning and statistical significance. Sir actually started with basics. Clearly, he moves towards what is the importance of the machine learning, and next he has shown how to classify the pearls, how to classify the human teeth, whether it belongs to male or female, and classification of the plastics. Sir has clearly explained the real-time examples. Thank you so much, sir, for your patience. Thank you.